All right, I think we're ready to get going. Advent of Code 2019, day 4. Secure container. You arrive at the Venus Fuel Depot only to discover it's protected by a password. The elves had written the password on a sticky note, but someone threw it out. However, they do remember a few key facts about the password. It's a 6-digit number. The value is within the range given in your puzzle input. Two adjacent digits are the same. Going from left to right, the digits never decrease. Okay. They only ever increase or stay the same. Other than the range rule, I guess this is the input here, right? It's not a separate file. It's just splatted into the text. The following are true. 111 matches these criteria. Double 1 never decreases. 2, 2, 3, 4, 5, 0 does not because it goes from 5 to 0. And 1, 2, 3, 7, 8, 9 does not because there's no double. Okay. How many different passwords within the range given in your puzzle input meet these criteria? All right, so there's nothing really to parse. I guess we could just split the number here. I mean, we do. It might be a little much, but we'll do it this way anyway. Let's put the number up here. Const range stir equals this. Let low high equals range split once on minus wrap. So now all we need to do is convert these into numbers. Phil says standard ops range. Yeah, we could do that. Range. And I think this is all VU size. So I think I can just do it like that. Let's find out. Yeah, that works. And then we can just say self range equals low dot dot high. Oh, range inclusive. We have to do range inclusive. Except these have to be numbers, obviously. Let low equals low dot parse usize unwrap. And what doesn't like trait default is not implemented for range inclusive. All right, so we can't do that. That would have been nice. Low, high. Yeah, I definitely need, oops. I need default there because of my the wacky way I do things. I mean, I suppose I could just implement default on my own for it. Oh no, it could, I can't do it that way. So with these two, now all we need to do is loop over every entry and every item for part 1. And for num in, this is going to be a little hard because we need to validate the number here, right? For num in self low dot equals self high. And the good news is they're all going to be 6-digit numbers. So actually, we could just do it this way, right? We can say let count equals self low dot equals self high. Map validate num count. And we could just output the count. And we don't have validate num yet, but we can make it, right? It should complain that it doesn't exist. Ooh, extract into variable. I was hoping it would allow me to just create the function fn validate num. And these are going to be usizes. And I think I have to put it as a reference, otherwise it's going to complain. Oh, filter map, right? because we want to return an option unit. We just care whether it's some or none. What doesn't it like? Oh, it has to extract it this way. Oh, maybe this doesn't have to be a reference. I keep forgetting when this needs to be a reference when it doesn't. Yeah, there we go. And we can also say some like that, and it should be all of them. Yeah, so that's, so I don't know, I didn't really point it out. This was 0 before, and now it's 467,000 something. If I change it back to none, it goes back to 0. So now we should be able to validate each number and then just get the count this way. So we need monotonically increasing. So if we split all the digits, do I convert it back to a string and do it that way? Or convert it into an array of digits? And it almost makes sense to make it easier to just do strings for everything, but then incrementing a string is painful. Altitude says array of digits is faster than string. Maybe. You still have to split it into the array of digits. If I do it this way, let's see, if I say let vals or digits equals format bang num, and then I want to say split, I can say chars collect vec. This has got to be pretty slow, right? Now it's a vec of char, and we can just enforce the fact that we have let has double, it's false. And then we can say for digit in digits, we'll need the previous digit. I guess we just grab the first one. Let mut iter equals digits iter. So this should be an iterator here. And we can just say let mut prev is equals iter next, unwrap. Right, so this will be a reference to a character. Okay, fair enough. While let some digit equals iter next. Using Windows, yeah, but we just need to be able to also check to see if we got an equality, a pair of equal digits. Yeah, Phil, I'll try that. Let me get this here and see if it works. If prev equals digit, then has double equals true. Else if prev is let's see if we can compare characters like this. Less than digit or greater than digit, then return none. And then this is going to be if has double, some, else none. Oh, and I have to reassign prev equals digit. Thank you, Rust Analyzer, for letting me know. So we got 2814. Let's see if that's right, and then we'll see if we can make this, that is the right answer, good. And we'll see if we could make it a little smarter. Let's try that, the Windows idea. I think, so that'll tell us if everything is less, yeah, so we can put less than or equal to, let, it's not monotonically increasing, so we can just say increasing. Let's just, do we have to say as slice first? Let's see, because I think you can only do Windows on slices. right? It does return a bool. Okay, so maybe we could do it that way. But then we also have to make sure that there's at least one that's double. Does filter map have to only do options, or can it? It has to be an option. Because returning unit is kind of weird. All right, so then we say if it's increasing and double, then some, else none. And we'll see if we come up with the same answer, 2814. Yep, 2814. It's certainly a lot cleaner, right? It's certainly a lot cleaner. The efficiency is secondary in terms of the number of digits or number of things we're actually comparing. Yeah, I'm happy with that. Thank you, Phil, for the idea. Git diff. Yep. So this is just part one. Git commit -am 2019 day 4 part 1. All right, let's see what part 2 is. It should be a little harder. And Elf just remembered one more important detail. The two adjacent matching digits are not part of the larger group of matching digits. Given this additional criterion, but still ignoring the range rule, the following are now true. So this no longer meets the criteria. So we can only have... Oh, this meets the criteria because it has a double 2, even though there's a 4 in here. As long as there's only one double. I think that complicates this. I mean, we can still use the increasing, right? The only question is there a way that we can convince? I'm trying to think, if we expand this window to 3, can we do it? Yeah, we would have to skip over. Yeah, we can't do that because we say, okay, this has 3 1s. This is no good. And then if we go to this, it would say this 3 1s no good. It would see a 1 1 2 and say, oh, there's 2 1s there, so it must be okay. Thus, that's not we can't just use a window of 3. Fn validate single double num size. We can still use this though, because if interesting is false, if not this, then none. So now we know everything's increasing or the same. Let me just do this to make the error go away because it's kind of annoying me. Part 2 is going to be this, except validate single double. So what we could do is we could just count the number of digits as we go along. We could just iterate, right? If, or, do we have to do that same thing I was doing? See, I'm defaulting to iterative mode here. Non-functional programming. Iter next unwrap. Let mut count equals 0. While let sum digit equals iter next. If prev equals next digit, and count plus equals 1. Else, we're going to say if count equals 2, then we can return sum. Otherwise, we'll say prev equals digit and keep going. And count. Oops. Count equals 1, right? Because we start off with 1. Will that do it? So the next digit is equal to previous digit, and the count goes up to 1, and then we assign that. That's fine. We don't want to reset the count to 1. We want to set the count to 1 here. And I keep forgetting semicolons. And so the previous is equal digit, we increment the count, we come down here, set that, we get the next digit, count might go to +1, that's fine. If the digits are not equal, then we'll come here. And if the count is 2, then we found a duplicate, we found a double. Otherwise, we're going to start over with the current digit as count of 1. All right, let's see if that works. We got 2898. Answer is too high. All right, so let's see if, let's run the tests then. Let's see, test, fn test 1, assert, bang, validate single double 112233. Let's flip this over to testing and save. Oh, it's an option, is sum. Okay, that one works. What's the other number? 12344 is bad. Okay. This should be none. That failed. Okay. It might be because I'm not checking the last one here, and I'm always returning sum at the end. So maybe we have to say if count equals 2, then sum else none. Let's see if that fixes the test. It does. Okay, that might be the bug. Let's run this guy just to be on the safe side. This should be sum. Yeah, that passed the test. Okay, let's run. We got 1991. That's smaller. It did say my answer is too high. So, hey, that's the right answer. Okay, so that was the bug. I was just not checking the last one. I assumed if we reached the end, it was good, which is obviously wrong if you think about it for more than a millisecond.